of Redox equation continued. Let's check the example on the board. Balance the Redox equation MnO4 minus plus I minus to give you Mn2 plus iodine atom. So this is an example of a Redox equation because if you check, the oxidation number of manganese changes from +7 to +2. That is to say that oxidation number of manganese atom in this is +7. So from here to here, it has changed to +2. While the iodide ion changes from -1 to 0. Here is 0. Remember, when it is uncombined, when it's staying in the uncombined state, is 0. You may ask me, is this one not staying alone? But don't forget that aqueous means that it is in solution, which means it is not standing alone. So that is why the oxidation number of iodine here is -1. And besides, it's not even iodine atom, it's iodide ion. So it's -1 to 0. Don't forget that the first step in balancing the Redox equation says that we should identify oxidizing agent and the reducing agent. How do you do that? You do that by considering their oxidation number changes. Consider the oxidation number of manganese here at the reactant side, and consider the oxidation number of the same manganese at the product side. If, like we have found out now, that the oxidation number of manganese is decreasing from +7 to +2, obviously is a decrease. While iodine changes from -1 to 0, obviously it is an increase. -1 to 0 is an increase. And I told you previously that every element or a species that has its oxidation number decreasing is actually the oxidizing agent. While that species that has its oxidation number increasing is the reducing agent. Don't forget the implication. That one that has its oxidation number decreasing is the one that is actually accepting electron. While that one that has its oxidation number increasing is actually losing electrons. Don't forget that fact. But I will show you how the oxidation number of manganese in this molecule on this ion is +7 before you will get it confused. Let us see how it is +7. Okay, check on the board. Don't forget that this one is an ion, and that is why I equate the whole thing to -1 normally. If not for this charge at the top, on top of this ion, it could have been 0 here. But don't forget, anyone that has charge, equate it to the charge. Anyone without charge, equate it to what? 0. That is the way to find oxidation number. Let us confirm whether oxidation number of manganese here is +7. So I equate the whole thing to -1 because of the charge. Manganese plus oxygen is -2. I have told you anywhere that oxygen is -2. That is the oxidation number of oxygen. -2 times 4. We have 4 oxygen molecule here, equal to -1. So manganese is -2 times 4 is -8. The plus has run away, equal to -1. Manganese equals -1 is here. When this -8 is crossing this sign, it becomes +8. So when you do the arithmetic, -1 plus 8 equal to +7. That is why manganese is +7 here. Manganese is +7 here. And it is changing to +2. Now, let us now identify oxidizing agent and reducing agent. Don't forget what I told you earlier. If you see the oxidation number of any species decreasing, it's oxidizing agent. So that's why I put this whole thing here as an oxidizing agent. Why this one is the reducing agent. Now, the next step is for us to write the two half equations. One for oxidation half equation, the other one for reduction half equation. Let us see how it goes. The example on the board, remember we are dealing with oxidation half equation. Now, the one you will represent, having identified the oxidizing agent and the reducing agent, the next thing to do is to write the half equation for oxidation. And remember that the one you will represent in the oxidation half equation is the reducing agent, because that is the one that is actually oxidized. That is why I represented iodine at the oxidation half equation. That is why it is there. It is the one that is oxidized. That is why iodine is there. So let us start the balancing now. Let us consider, we balance two things. Remember, number of atoms and now the number of charges. The number of atoms now, is it balanced? Let us check. Here is one iodine. Remember, one is here, but we have two iodine here. So what do? We put two at that place. So we put two here. We put two there. That means the number of atoms is now balanced. What next are we required to balance? Number of charge. Number of charge. Number of charge. Let us consider the number of charges here. This side we have -2. And this side we have what? 0. How is it -2? This is affecting this minus here. That is -2. And here is what? 0. Remember, in the uncombined state is what? 0. Now, how do we balance number of charge? Don't forget the rules that we should place accurate number of electrons at the appropriate side of the equation. Now, how do we balance it? Think, how do we balance number of charge? How do we balance number of charge? Look at what I'm going to do now. Balance number of charge. Iodine here. Give me iodine solid plus 2E. If you add 2E, you have to add electron now. But when you are adding 2, don't get it twisted. We are trying to balance number of charge so that this side will be +2, this side will be plus, this side will be -2, this side will also be -2. Instead of removing and adding, but if you know mathematics very well, in as much as I have added 2E, it's invariably -2. So when you check now, here is -2. Don't forget. And here now is 0 -2. Here is 0. And here is this minus here has taken over this -2, and the plus has what? Disappeared. So here is -2, and here is -2. The number of charge there is now balanced. That is to say, to balance number of charge in oxidation half equation, you add electron at the right hand side of the equation. To add number of charge or to balance number of charge, we add electron at the right hand side of the equation. Maybe when we will be going over to the reduction half equation, we will know the side we will add electron in order for the equation to balance. It is now balanced. Oxidation half equation is now balanced. Let us go to reduction half equation. Let us go to reduction half equation. Reduction half equation. So we are representing manganese there because we are representing oxidizing agent there in reduction half equation because it is the one that is what reduced. Don't forget, from +7 to +2 is reduction. So that is why it is represented in reduction half equation. So if you watch, you see how I'm picking my product. You don't take unlike terms. You take manganese and manganese are the reactant and the product. Just that is how it is. Now, don't forget that at the reactant side there we have oxygen. What do we do? Remember the rule, the steps. Add water, accurate number of water and all the rest of them at the appropriate side of the equation. Let us see how it goes. Okay. Look at it on the board. To balance number of oxygen, I added water at the right hand side. Because here contains oxygen and there is no oxygen here. Remember, formally it's like this. So to balance oxygen here, I add water. It is in that step of balancing redox equation. And remember, we are trying to balance oxygen. That was why we added water here. And don't forget that once water has been added, hydrogen is always there. So in order to balance hydrogen here, remember balancing of equation, whether redox, nuclear, ordinary chemical equation. All we are doing is that what is at the left hand side will be at the right hand side so that they balance each other. So to balance that hydrogen now, I added hydrogen here at this side. So here now, here has manganese, here has manganese, oxygen is here, oxygen is here, hydrogen is here, hydrogen is here. So the next thing now is to start balancing. First, balance number of atoms. Manganese 1 at the left hand side, manganese 1 at the right hand side. Oxygen 4 here, but oxygen is 1 here. So what do? We add 4 here. So we add 4 here. Remember, oxygen is 4 here, but it's 1 here. So that was why I added 4. So this now, oxygen now has turned to 4. Hydrogen now is how many? 8. 4 times 2 is 8. So we are adding 8 electrons here. Let me amend that. 8 electrons there. So the number of atoms, they are now balanced. 1 manganese, 4 oxygen, 4 oxygen, 8 hydrogen, 8 hydrogen. Now let us check number of charges. Let us check number of charges. At the right hand side, at the left hand side, we have -1 plus 8. -1 plus 8. That is what we have here. -1 plus 8. Why do we have only +2 here? Remember, water is neutral. It has no charge. Let us see how it goes. So look at it there. The number of charge there is +7 there. -1 plus 8 is +7. And here is only +2. This one is neutral. So now, how do you balance it? Since the charge of this side is +7 and charge of this side is +2, it's not balanced now. So you ask yourself, how do we balance it? So that either both of them is +2, or they are +7, +7. Look at what I did. Look at what I did. I added 5 electrons here. So that these 5 electrons I added now, when you minus +7 minus 5, it will give us +2. It will give us +2, which will balance this side, which is +2. So that is it. So just -1 plus 8 minus 5. Here is +7 minus 5, which will give us +2, which will balance this side, which is +2. So I added 5 electrons at the left hand side for reduction half equation. Don't forget, when we are dealing with reduction half equation, we added electron at the right hand side. But for reduction, add electron at the left hand side of the equation to balance number of charges. Don't forget it. So number of charges now is now equal. Here is +2 and here is +2. The next thing to do, don't forget that the last one says, the last step for balancing this equation says, let the electron lost here, because two electrons has been lost here, and the electrons gained here. Let them balance each other, which means +2 and +5, and the +5 electron, they must be equal. Let us see how to balance the. In fact, let us call this one equation 1 and call this one equation 2. So that the number of electrons lost in equation 1 should be gained in equation 2. Let us check. So what do we do so that the two sides of the equation will have the same number of electrons? Let us think of what to do. What if we multiply equation 1 by 5? So that 5 times 2 will give us 10. And we multiply equation 2 by 2. So that 2 times 5 will give us 10. Remember that the electrons on the two half equations must be equal. So I am suggesting to multiply equation 1 by 5. So that 5, when it multiplies 2, it will give us 10. And multiply equation 2 by 2. So that 2 times 5 electron will give us 10. Let us see how it goes.